So on page 530, right above that chart that you were filling out, there's a graph of sine x. Some of the things about sine x from before. The period, the amount of time it takes to repeat itself, and this is for y equals sine of x, is 2 pi. Its amplitude, which is from the middle to a maximum or from the middle to a minimum, that distance, so here's our middle, our sinusoidal axis, this distance right there is our amplitude. That's going to equal 1. Yes?
Is also the number before sine or everything?
Whatever number's in front of sine will affect the amplitude, yes. So whatever that a value is going to affect our amplitude. The domain of sine is always everything. The range, however, the smallest value is -1, and the biggest value is +1. So in interval notation, we could write from -1 to 1. And finally, if you wrote all of your x-intercepts down, they would all be in the form of something times pi, where that something, the k, is any integer. So this is just some of the basic things of a regular sine graph that we looked at when we did section 6.5. Now, taking that into consideration, we can now start to fill out this chart. This 2x inside is going to be a horizontal compression. It's going to squish everything and multiply all of our x values by 1/2. So that's going to affect your period. Your period was 2 pi. Now it'll just be pi. One of the things that we looked at before was this additional formula that your period is equal to 2 pi divided by whatever your b value is. So since our b value is 2, our period is going to be 2 pi divided by 2, which simplifies to just be pi. The amplitude of this function is still 1, because squishing it horizontally will not change how far it is from the middle line to a maximum. The domain is still everything. The range still goes from -1 to 1. There is no phase shift. You're not moving it left or right. And the zeros now, they were k pi, but now that we've multiplied everything by 1/2, this will get multiplied by 1/2 as well. So our zeros are now k pi divided by 2. For the second one, the only thing different now is we're adding 1/2 in front. That's going to squish things vertically, compress it by a factor of 1/2. What that's going to change is that's going to change our amplitude is now going to be 1/2, and our range is now going to be -1/2 to 1/2. What's not going to change is the period is still going to be pi like it was before. The domain is still going to be everything. There's still no phase shift. And squishing it vertically will not change the fact that our zeros are still k pi over 2. What's going to happen if we add an x minus pi over 4 inside the function? That's going to move things pi over 4 to the right. Everything else is going to stay the same from the previous one. So our period is still pi from the previous one. Our amplitude is still 1/2. The domain is still everything. The range still goes from -1/2 to 1/2. And the zeros are still k pi over 2, where k is an integer. Finally, we have a -3. That's going to move everything down 3. So as far as our phase shift goes, we're still going to have pi over 4 right, but now we're going to add to it that we're going down 3. What else will moving something down 3 affect? The range is going to get affected, because it used to be from -1/2 to positive a half. When you move it down 3, it'll go to negative 3.5. And if you move from a half, go down 3, it's going to go down to negative 2.5. What else is going to get affected? The amplitude is still going to be a half, because if you think about this, your center line now is at 3, and it's still a half to the top and a half to the bottom. Or sorry, the center line is at minus 3. So our amplitude stays a half. But the other thing that's going to be affected are your x-intercepts. Because now, if you think that your range is between negative 3.5 and negative 2.5, will that have any x-intercepts ever? No. So now, all of a sudden, your zeros in this one, there's none. The other things, your period would still be pi, and your domain is still everything. Those ones will change. Now at the top of page 531, what I'd like you to write down is we're going to learn a special order for graphing both y equals a sine b x minus c plus d and y equals a cos b x minus c plus d. So if you had all of the transformations, what we've learned in the past is you would go from left to right. A is going to be a vertical stretch. B is going to be a horizontal stretch or compression. C is going to move it left or right, and D is going to move it up and down. And that's what we did in our transformations unit. But looking at some of the patterns that we noticed when we looked at the A, the B, the C, and the D value individually, when we looked at the last section, we can create a shortcut for graphing these that'll be easier. The shortcut, the way that I like to call it DAB C. What you're going to do is you're going to start with your D value, which is your sinusoidal axis. And you're going to draw a dotted line, whatever your D value is, as your sinusoidal axis. So with our previous example, the one that was right at the end, this one here, 1/2 sine 2x minus pi over 4 minus 3, whew, I'll draw that as we go through the steps. So if I was starting with my sinusoidal axis for this one, the first thing I would draw, 1, 2, 3, is a dotted line at y equals negative 3. The next thing you're going to do is A. You're going to use your amplitude to find your max or min. So if our amplitude is a half, we'll go up a half to negative 2.5, down a half to negative 3.5. That'll be your max and your min. You're going to use your B value to find your period, and you're going to make 4 sections. So we found out that our B value made a period of pi. You'll label pi and split it into 4. So half of pi is pi over 2, half of pi over 2 would be pi over 4, 1 pi over 4, 2 pi over 4, this will be 3 pi over 4. And once you've done the DAB part, then you're going to graph things. Now, a sine graph normally starts where? It starts in the middle. Starts in the middle, goes to a max, back to a middle, down to a min, and then back to the middle again. And we'll draw this with a dotted line. And that's a start for what our graph. All we'll have left is the C value, which is moving it left and right, and we'll do that tomorrow.